So if you watch all the videos, we can combine all the pathways into one complex mole roadmap.
A lot of people will be scared here. A lot of people will be scared, and I'll name them.
So from mole, you can go to any other directions. You can also make multiple journeys or have multiple stopovers using this mole roadmap.
Excuse me?
How many grams are there in 7.5 times 10 raised to the 23rd molecules of H2SO4? So H2SO4 is sulfuric acid. So here we are given the number of molecules and we want to get the number of grams. As you can see, there is no direct conversion between number of particles to mass. So in order to get the mass, we need to solve for the number of moles first, then we get the number of mass. So the plan will be molecules to moles to mass. So again, let's write the table. So write the given to the upper left, molecules. Now copy this one. So we have number of moles in the top and the number of particles or molecules in the bottom. Let's cancel the units. We are now in mole. So again, if you have the number of moles and you want to get the mass, you have to compute for the molar mass. Let's solve for the molar mass. H 1.008 times 2, you will have 2.016 grams per mole. For sulfur, you have 32.07 times 1, you will get 32.07 grams per mole. And for oxygen, 16.00 times 4, you will have 64.00 grams per mole. So why times 4? Because you have 4 oxygen atoms. Solving for this, you will get 98.086 grams per mole. Now let's use this conversion factor since we want to go to mass from mole. So copy the molar mass, 98.086 grams over 1 mole. So we will cancel this. Now we will have the grams. So solving for this, we will get 122.15958 grams. Since the given has only two significant figures, our final answer should also have two significant figures. So we need to use scientific notation. We will have 1 10 raised to 1 grams of H2SO4. But if the given has three significant figures, we will have 122 grams of H2SO4. That's why significant figures are important.
It was therapeutic for me. I don't regret it.
Calculate the mass of 300 liters of dinitrogen monoxide. Here we are given the liters and we want to get the mass. So again, there is no direct conversion, so we need to go to moles first. The plan will be volume in liters, go to moles, go to mass. So we want to follow this pathway. Okay, so the first step is to write the table. Write the given to the upper left, 300 liters. Then copy the conversion factor so that the liters will cancel, 22.4 liters. Now we have moles. Then you have to copy this, molar mass over the 1 mole so that the mole will cancel. Now let's solve for the molar mass. Dinitrogen monoxide is N2O. N is 14.01 times 2. This will give us 28.02 grams per mole. For oxygen, we have 16.00 times 1. This will give us 16.00 grams per mole. Now get the sum. We will have 44.02 grams per mole. Copy the grams here. So cancel this. This will give us 589.553 grams. So since the given has only one significant figure, the answer will be 6 times 10 raised to the second power grams, or 600 grams.
Be like, okay, this here.
So how many molecules are in 720 grams of C6H12O6?
Wow, that's a great question. I wasn't expecting that question.
So C6H12O6 is glucose, and we want to get the number of molecules given the mass in grams. So we're going to follow this pathway. Okay. First step is to get the molar mass of the compound. So C 12.01 times 6 H 1.008 times 12 O 16.00 times 6. Okay, so solving for this. So the molar mass will be 180.156 grams per mole. Now that we're all set, let's make the table. Okay. 720 grams to the upper left. Then copy this. So 1 mole in the top, then the molar mass in the bottom. 180.156 grams. Cancel the grams. We're now in the mole. We have to copy this 1 mole in the bottom and Avogadro's number in the top. So 6.022 times 10 molecules. Cancel, cancel. We are now in the molecules. Now solve. This will give us 2.406 molecules. Since the given has only two significant numbers, our answer will be 2.4 molecules.
How?
So how many moles are there in 450 grams of Na2SO4? So in this problem, we are asked to solve the number of molecules given the grams. So the first thing that you should get is the molar mass. Okay, so Na2SO4 is sodium sulfate. So Na, S, and O. So from the periodic table, sodium has 22.99. Since you have two atoms of sodium, multiply this to 2, you will get 45.98 grams per mole. For sulfur, you will have 32.07 times 1. Since you have one sulfur atom, you will still get 32.07 grams per mole. For oxygen, you have 16.00. Since you have 4 atoms of oxygen, times 4, you will get 64 grams per mole. Now get the sum of these three. We will have 142.05 grams per mole. So there is no direct conversion for mass to molecules. So what we need to do is to convert mass to moles first, then convert the moles to molecules. Okay, so this will be the plan. Okay, so the plan will be mass in grams times 1 mole over the grams. Cancel the grams. This will give us the mole. Then to get the molecules, we need to multiply it to the Avogadro's number. So the moles will cancel, leaving us the molecules. Now let's use the conversion fact. First step is to draw the table. Write the given to the upper left. So 450 grams. Now copy this conversion factor using the molar mass. So 1 mole over 142.05 grams per mole. Then copy this relationship over 1 mole. Look how the units cancel. Grams will cancel, then cancel moles. This will leave us the molecules. Solving this equation, this will give us 1.90770 molecules. And since the given has only three significant figures, our final answer will be 1.91 molecules.
Thanks everybody for coming out. I know y'all didn't expect me. Thank y'all so much, especially you in the back right there.